Okay, so let's talk about the info that you can get from the periodic table. All right. The first thing we need to understand, the first thing we need to label are kind of the groups of the periodic table. Okay. So this first group, this is your alkali metals. Group are alkaline earth metals. Whole middle section right in there. Those are your transition metals. These down here, they have individual names, the lanthanides and actinides, but we call them collectively the intertransition metals. All right, now, everything on the left side is metals. Everything on the left is metals. Everything on the right is nonmetals. All right, so the question is, where's the left and where's the right? And what we have is a stair step that separates the left from the right. So this stair step is going to start there and literally look like steps all the way down the periodic table. Okay, so that's where it's at. That separates metals from nonmetals. Okay, there is no real name, or there's not a name that you all have to know for these metals right here. All right, they're metals. All right, now I'm going to circle a handful here in a second. All right, I'm going to circle a handful here in a second, and those are metalloids. Okay, metalloids. Metalloids have properties of both metals and nonmetals. So which ones are the metalloids? We're going to start with boron, all right, and then silicon, germanium, arsenic, antimony, and tellurium. Those are your metalloids. Okay, oh, sorry, and polonium. Polonium's a metalloid as well. So those circled ones, all right, those circled ones are your metalloids. So everything to the left, again, everything to the left is metals. Everything to the right of the stair step are nonmetals. This group right here, this group is your halogens. Okay. This final group, these go by two names. Noble gases is one. They could also be called inert gases. Okay. Inert because they don't react with anything. They don't combine with anything. Noble gases, noble kind of referring to the fact that they don't react with anything as well. So those are the just the names of all the groups that you need to know. Okay, so that's the basics. So when I ask you, what group is sodium in, you are going to say the alkali metals group. Okay, if I say what is the big group in the middle called, that's transition metals. Okay, so let's move on down to what else can we gather from the periodic table. First of all, I'll tell you that the groups, those are your columns, and they're also called families. Groups are columns, and they're also called families. And they are called families because they have similar properties. Okay, so if you're looking at this this first alkali metal group, lithium, sodium, potassium, rubidium, they all have similar properties. Okay, actually, let's go back. If you go back real quick, obviously hydrogen does not fall into that metal group. It is a non-metal, so it would go all the way to the right with the rest of the non-metals because it's a gas. It's kind of obvious, but I want to say it anyway, so you all don't get confused. anyway, groups have similar properties. They're also going to have the same number of, they're going to have the same number of valence electrons, which we talked about in the last unit. They're also going to have the same number, or sorry, the same charge. Okay, they're going to have the same charge. Because they have the same number of valence electrons, they're going to lose or gain the same number of electrons, thus creating the same charge. All right, so if we talk about groups, group 1 here is going to have 1 valence electron. Group 2 is going to have 2 valence electrons. We're going to skip all these, skip the transition metals because they don't follow the same kind of rules. Group 3 has 3 valence electrons, 4, 5, 6, 7, and 8. That's stuff we've talked about in the last unit. If we're talking about charge, okay, we're talking about charges. Everything, and I'll write this on the bottom, everything on group 1, because it has 1 valence electron, it's going to lose that valence electron. And because it's going to lose it, it's going to come up with a +1 charge. Okay? So if you were to draw, if we drew sodium real quick up here, all right? Or sorry, we'll just do lithium. Lithium, it has 2 electrons here and it has 1 electron here. That 1 electron is going to go, okay? It's going to leave because, you know, the atom wants to do what is most, it's basically wants to do what's easier. So it needs to get a full octet. It needs to get a full outer shell. So is it going to be easier to get rid of the 1, or is it going to be easier to gain 7 electrons? And it's going to be easier to get rid of the 1, so it's going to get rid of the 1. And we're going to end up looking like this. Now, we only have 2 electrons, but we have 3 protons. So that's going to be an overall +1 charge. Okay? Same thing would be said for beryllium, magnesium, calcium, this group 2. They're going to create a +2 charge because if we look at the same type of element here, okay, instead of lithium, we talk about beryllium, which now has 2 valence electrons. It's going to be easier to get rid of 2 than it is to gain 6. So they're going to get rid of those 2. So now we have a similar looking atom. It has 2 electrons, but it has 4 protons, creating an overall 2+ charge. Okay, this whole third column. Okay, this whole third column is going to create a 3+ charge. Okay, now column 4. You know, when you talk about what's going to be easier, is it going to be easier to get rid of 4 or gain 4? They can kind of go either way. So I kind of just tell everybody, let's go plus or minus 4. I usually won't use that in an actual scenario though, or a question. Once we get to group 5, now you've got 5 electrons. Okay, you have 5 valence electrons, and you want to get to 8. So if we talk about nitrogen here. Okay, it has 5, 1, 2, 3, 4, 5. It's going to be easier to gain 3 than it is to lose 5. So it's going to gain 1 here, here, and here. So now it's gained 3. So now what you have is something that looks like this, where you've got 1, 2, 3, 4, 5, 6, 7, 8 valence electrons. So now you have, sorry, plus the 2 in the middle. So now you have 10 electrons, but you still only have 7 protons. So overall, you have a -3 charge. Okay, so everything here is going to give you a 3- charge. Group 6, charge. Group 7, you're going to get a 1- charge. And then group 8, because group 8 already has a full outer shell, they are not going to get rid of or add any electrons. So because they have a full valence shell already, they don't react with anything, they do not create a charge. These are neutral. Okay, they will not create a charge. So that's your groups. That's what groups tell us. Okay, that's a couple of things that groups tell us. That's if you're going top to bottom. Okay, that's if you're going in columns. If you are going, let's go down one more. Let's talk about periods. Okay, periods. are your rows. Okay? Periods are your rows. So this is period 1, 2, 3, 4, 5, 6, and 7. Okay? Period 1. So if I ask you, what period is magnesium in? Well, magnesium is right there. That's in period 3. Okay? Now, what do periods have in common? So periods have the same number of energy levels. Okay? Same number of energy levels. So everything in period 1 is going to have one energy level. So if you look at hydrogen, we'll draw this real quick. It has one energy level with one electron. Helium has one energy level with 2 electrons. Okay? Now, one thing you need to understand is that each energy level can only have so many electrons in it. So, energy level 1 have 2 electrons. Level 2 can have 8 electrons. Level 3 can have 8. Level 4 can have 18. Level 5 can have 18, and so on. Okay? So, level 6 can have 32. So 2, 8, 8, 18, and 32. Sorry, 2 18s and 32. All right? So after this 2, we can't put any more here. So lithium can't have a third one there. So lithium has 2 energy levels. So when we draw lithium, we have our 2 electrons there, and then we have a second energy level. Okay? If we go all the way across to beryllium, to boron, carbon, nitrogen, all those good old things, you're going to keep on just filling in this outer shell right here. Okay? So if we wanted to make this, lithium nitrogen, well, nitrogen it's in group 1, 2, 3, 4, 5, 6, 7, 8. It's in group 5. Okay, so it's going to have 5 valence electrons. So 1, 2, 3, 4, 5. That's nitrogen. It has the same number of energy levels as lithium. So if I asked you how many energy levels, if I asked you, what row or what element, magnesium, calcium, or strontium, what element has valence electrons in the 4th energy level? Well, valence electrons are on the most outermost energy level. Calcium has 4 energy levels, so that's where calcium's valence electrons would be in the 4th energy level. Okay. So you need to be able to determine, what number of energy levels each thing has, or each element has.